So with an ellipse, we just talked about how an ellipse's shape is an oval shape. Okay? Vertices on an ellipse are always on the longer side. Oops, if I can spell longer. Let's try this again. Okay. Now, so there'll be one side that is longer. The vertices are on the outside, and they are only on the longer axis. Okay? Ellipses should always equal 1. If they do not equal 1, divide so the equation is equal to 1. This is an example of an ellipse equation. Okay, now the easiest thing to remember is see right here how you have your x term. The value underneath is going to tell you how far you're going to go out on the x-axis. Okay, but it's just going to go out a distance. So see how a squared is on the bottom? We're going to take the square root of a, and that would tell you how far to go from the center on your x-axis. Okay, same thing with the y. Okay, the y, the value underneath the y, you take the square root of that value, and that is telling you the distance to go on the y-axis. Okay, your center is always dealing with your x and y values on top. So in this case, see how there's no parentheses? What's going to be my center on this first graph? 0, 0. But if there was parentheses, we'd take the opposite value out, right? And then we would make our center a different place. Okay, so in this case, my center is at 0, 0. Okay, so I'm going to go ahead and mark 0, 0 on here. Okay, for my x, okay, my x-axis here, on the bottom of the x is 25. So in order to find out how far of a distance I'm going to go on my x-axis, what am I going to do? Good. Take the square root of 25, and the square root of 25 is what? 5. So that means on my x-axis, I'm going 5 in each direction. 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5. Then we go to the y. Right now, y is 16. So we take the square root of 16, which is 4. Very good. And so that means we're going to go up and down 4. 1, 2, 3, 4 up, and 1, 2, 3, 4 down. And then we will draw our ellipse, which is an oval type shape. What? It does look like a circle because if you think about it, 4 and 5 are very close, but some of them will be like 2 and 7. It would look a lot different. Okay? Now the vertices, we said the vertices are on the, go back to the beginning, the vertices are on the longer side. So which side is longer? Which value do we go out further? On the 5, the x-axis. So that means these right here are my vertices. So we are going to write each of those ordered pairs. There's 2 vertices. There's 2 values on the outside here. So one of the values is 5, 0, and also negative 5, 0. What would be a shortcut for writing that if you wanted to have a shortcut? Anybody know? Good. You could also write this as plus or minus 5, 0. Okay, they won't all work that way because sometimes it'll be different values, but you can write it that way if you wanted to. Are there questions right now on this example? No? Okay, moving on to example 2. If you notice on this one, it is equal to 36. At the beginning, if you go back and look at your standard ellipse equation, they told you that it always needs to be set equal to 1. This is not set equal to 1. So what do we do?
You move the 36 over.
No.
Divide by 4.
We divide every single term by 36. Okay? So we're dividing each of these by 36. Okay, when I do that, 4 goes into 36 how many times? 9. So we have x squared over 9. Okay, plus, here I have y squared over 36 equals, and 36 divided by 36 is 1. Okay, what is my center on this? 0, 0, because we're always looking at the values that are with the x and with the y on top. Okay, there's nothing there, so it's 0, 0. So we'll plot our 0, 0. Okay, how far will I go on the x-axis? 3. Square root of 9 equals 3. So I go right and left 3. Okay, on the y-axis, how far am I going to go?
6.
Good. Square root of 36 is 6. So we're going up and down 6. Okay, and this one looks, I'm sure, more like an oval.
Yeah.
Okay, so what are my vertices on this problem?
0, -6.
Very good. 0, 6 and 0, -6. Questions? Okay, example 3 is slightly different.
So on that one, you can put 0, plus or minus 6.
Yes, you could also do 0, plus or minus 6 on this one. That is correct. That means the same thing. Okay, because that's saying 0, 6 and 0, -6 when you have plus or minus. Vertices?
You put the longest one?
So whichever side is the longest, that's it. Okay? Any other questions right now? These are all good questions. No? All right, so how is example 3 different from the others?
It's not.
Good. Also, they had the parentheses kind of written differently. I want you to realize, okay, that whenever you have the whole parentheses around this, that means that the top's squared and also the bottom is squared. If that is confusing to you at all, you could always rewrite this problem and write it as x squared over 2 squared, which would be 4, plus, and then y minus 2 squared over 4 squared is 16 equals 1. If you want to see it that way, you can change it if you want to, okay? So, but on this one, there's a value with the y, so when I write my center, what is my center on example 3? 0, what? 2. Because we always take the opposite of what's in the parenthesis with the y. Correct? Okay, so let's go ahead and go 0 and then up 2. This is my center. So this is where I'm going to be counting each direction is from this center point. So it's going to change things up a little this time. So for my x value, how many am I going to go in each direction? 2. Okay? Because, and if you wanted, we did the square root of 4 equals 2. So the x direction, so from here I'm going right 2 and left 2. For my y, it's the square root of 16, which is 4. So we're going up 4 and down 4. And then we can draw our ellipse. And my vertices are on which axis this time? The y. Very good. So you need to make sure to count these points. I can't do plus or minus on this one because they are different values. So one of them is going to be what? 0, and it's 1, 2, 3, 4, 5, 6, right? 0, 6, and the other one is 0, -2, and those are my vertices.
I have a question about like the y minus 2 squared part. You don't like distribute the squared?
No, not on that, because you always want your top terms to be squared. So yeah, so that, remember, just whatever's in parentheses, you take the opposite. If there's nothing with the if there's no parentheses, it's 0. Okay, excuse me. You guys are being rude. I cannot hear questions, and you never know. Somebody might have a really good question that makes sense to you. You might even not know you have it until someone asks it, so you need to listen. Maddie. The whole fraction is squared. No, I squared that top one because I wrote it as x squared. And then I also squared the bottom, which is 4. Okay? Helena. Because what is the square root of 4? Is that okay? Okay, Nucci. Where did I get the 6? Because whenever you're giving your ordered pairs, gentlemen, do you not understand me about being quiet? Whenever we're doing vertices, you always, when you're counting, you have to start from your center, and that went up 1, 2, 3, 4, 5, 6. This point right here is at 0, 6.
So they don't start in the middle of where.
So like on the other one, see how my center was at 0, 0?
Oh.
So that's what made it a little different, because this one, my center wasn't at 0, 0, it's at 0, 2, so it kind of shifts things around a little bit. Will the center always be at 0, 0?
Look when you.
When you're counting, yes. You always start at the 0, 0 and then count.
Okay.
Other questions? Okay, let's move on to the next page. So what are we going to need to do on this one? Good. Divide by 648 to every single term. Okay, when I do that, 72 goes into 648. Anybody know how many times? Yes, thank you. 9 times is correct. So we have x minus 1 squared over 9 plus 8 goes into 648.
Wait, I have a question. How did that 9 get underneath the x minus 1 squared if the 72 was in front of the parentheses? Because that equals 1.
If you get in a calculator, 72 divided by 72 is 1. And then on your calculator, 648 divided by 72 is 9. So I took 648 and divided by 72, and I took 72 divided by 72. So do you see that in the calculator, how 648 divided by 72 is 9?
Yeah, I get the calculation part. It's just like I don't understand how you got the 9 underneath the x minus 1 squared.
Hold up. Going back here, remember here how I divided everything by 36? I'm just going to use smaller numbers because I think it's big numbers sometimes like throw off what we're doing. But see how here how I divide everything by 36? 4 goes into 36 how many times?
Oh, are you asking me?
Yeah.
Or are you trying to show me?
No, I'm asking you. 4 goes into 36 how many times? 9 times. So that's why I have 9 on the bottom here. Do you get that part?
Yeah.
Okay, it's the same thing here. 72 goes into 648 9 times. Oh, sorry. 72 divides into 648 9 times. So we're just reducing the fraction. Just like we did with the 4 and the 36. Does that make more sense? Okay. Okay, so then the same thing here. 8 goes into 648 how many times? 81 is correct. So now I have y squared over 81 equals, and then this reduces to just 1. Okay, so now what is my center on this problem?
1, 0, 1, 0.
Yeah, 1 comma 0 is correct. So let's plot that point. We go over 1 and up 0, so my center is there. That's my starting point for when I'm going each direction. How far will I go on the x-axis? Good, the square root of 9 is 3. So from this point, I'm going right 1, 2, 3, and I'm going left 1, 2, 3. On my y-axis, I'm going the square root of 81, which is 9. So I'm going up and down 9. The whole thing has 10, so I know I'm just going to go 1 from the top and 1 from the bottom. And then we can draw our ellipse. Okay, so what would my vertices, which axis are they going to be with? The y-axis, because that's the longer side. So these points, this point right here and this point right here, those are my vertices. Okay, so what are those values? What are those ordered pairs? Very good. 1 comma 9 and 1 comma negative 9. Okay, so now for the fun part. And when I mean fun, I mean work. Okay. Thank you. I actually can keep it going longer now. But I appreciate you guys remembering. Okay, so we need to put these in standard form. Whenever we're putting something in standard or descriptive form, we need to end up doing what? Completing the square. Whoever said that was correct. Okay, so just like yesterday, I need to put my x's together, and then I'll end up needing to put my y's together, and this plain number is going to go to the other side. So when I'm putting my x's together, when you notice your parentheses, you always, if there's a number in front of your x squared, you end up factoring it out, right? Just like in example 4, there was a number in front, but it's factored out. We can't have a number inside when we're completing the square, okay? So when I'm writing this out, what number am I going to factor out? A 16.
4.
No, I'm going to factor out a 16 because we don't want a number with the x squared term. So whatever the x squared term is, that's the number you're going to take out. Okay? So I'm going to write this as 16 parenthesis x squared plus, and then I have to go 96 divided by 16, which is 6 is correct. So 6x, and then what comes next? Plus your blank. Very good. Okay, then I have plus, and here's my y's. What am I going to have to take out in front of the y's? Very good, a 4. So I have 4 parenthesis y squared, and then negative 48 divided by 4 is? Good, negative 12x, and then what? Oh, thank you. And then what? Plus blank. Close your parenthesis, and this is going to equal what? Good, negative 32, and then what do I need still?
16.
Good, plus 16 times our blank, and then the other one will be plus 4 times the blank. Okay, Serena, question.
Is it always going to be plus the blank? It's not going to be minus the blank?
For ellipses, it's going to always be plus, but when we start doing hyperbolas, this term and middle term is a negative, and you'll get a, so then you'll end up doing an opposite.
All of these are kind of like reviews, huh?
Kinda. Well, I mean, this is, so with all of our conic sections, which is what we're talking about, there's a lot of similarities between each of them. Does that make sense?
Yeah.
But an ellipse is just a little different than a circle, and a circle was different than a parabola. Okay, so now we're completing the square. Some of you are already working ahead, which is amazing because you guys are so smart. But what do I do to complete the square on the x's?
Divided by 2.
Good. 6 divided by 2 is 3, and then 3 squared is 9. So 9 goes in each of my blanks with my 16 blank and my 16 blank. Okay, what will I do for my y part? Negative 12 divided by 2, which is
Negative 6.
negative 6. So negative 6 squared is
36.
36. Ladies, it does not look like you're taking notes, Courtney, are you? Okay. Okay, so then now we are going to write this out. So I have 16, and then we have parentheses, and it will be in the parentheses what?
X.
Good. X plus 3 squared plus
X minus 6.
4, and then y minus 6 squared, because remember it's always our half number, equals, and then now we're going to have a little bit of math over here. Okay? So we have negative 32 plus 16 times 9 is, very good, 144 is correct, plus 4 times 36 is 144. When we add and subtract there, we end up getting 256 is correct. So this number right here is 256 once I simplified all that. Okay, this is actually written, this is standard form, but we don't really, even though it says standard form, we want it in descriptive form, because whenever we're graphing these, it always has to be equal to what? 1. Okay? And so what am I going to do to write this into descriptive form?
Divided by
Good. Divide by 256 to every term.
Wait, so if this was on a test and it said standard form, will we leave it like that or will we still reduce it?
You would leave it like that.
Oh.
But what's funny is in your homework, it's like a typo. It tells you to write it in standard form, but then all the answers are in descriptive form. But if you're taking the CST test or the STAR test, they wouldn't make that mistake. So standard form would mean this. Okay? All right, so now we're just going to reduce this. And so 16 goes into 256 how many times? 16 times. Very good. So that means I have x plus 3 squared over 16 plus 4 goes into 256 how many times? 64 is correct. So I have plus y minus 6 squared over 64 equals, and then we divide both of those and it equals 1. And so that is my answer for descriptive form, which is what I want in your homework, okay? Okay. For time's sake, because some of you want to get your homework done, do you guys feel like we need to do another example, or do you guys get this? Okay, just so you know, if you did this on your own and maybe you want to try it on your own, once it's in descriptive form, it'll be x plus 2 squared over 9 plus y plus 7 squared over 324 equals 1. Okay? So that would be this answer if you went through completing the square and all that. Okay, real quick, example 7. Identify the following as a circle, parabola, or neither. Actually, it should have also had ellipse. Circle, parabola, neither, or ellipse. Let's add that in there. Okay, so who knows one of them for sure? A is what? Parabola. How do you know A is a parabola? Okay, what do you think B is? Good, and a key thing for circles is that the numbers in front, if they're the same, then that means like your radius would end up, everything would be the same. Because even if I divided everything by 8 here, I'd get 4 on each of the bottoms, and you'd go the same distance on the x and the same distance on the y, and if you do the same distance on the x and the same distance on the y, that's a circle, right? You with me? Okay, so this is a circle. Very good. On here, we have our 2 squared terms, but the numbers in front of the x's and y's are different, which means you'd go a different distance on your x and y, so therefore this one is a ellipse. Okay. All right, we are done for today.